How to build a variable displacement vacuum chamber. You'll need two check valves. These allow flow in only one direction. A small tube for the extraction cylinder, a shaft with a handle at one end and a gasket at the other. The 1/4-inch threaded rod is convenient but also acts like a saw, so you might want to reconsider or protect the cylinder end with some type of metal grommet. I have not taken this precaution yet. A small can of PVC glue is plenty. The vacuum chamber is made from a 4-inch pipe or larger. Simply reduce one end to receive a 1/2-inch pipe and a threaded cap on the other end. Teflon tape is your friend, both for sealing the chamber's end cap and the piston gaskets. A few elbows and other PVC connectors complete the reduced end. The first gasket attempt used rubber washers. These failed miserably due to the loose tolerancing and high friction. Instead, I made my own rubber gaskets by layering strips of old jeans and silicone caulk. Just clamp it between two furring strips. Too bad we don't have a vacuum chamber to remove all the air and make a denser gasket. The gasket is cut from the rubber jeans block with a razor blade and clamped to the rod with the assortment of screws, washers, and nuts as shown. The end cap will act as a vacuum release using a thick eye bolt. The inside of the end cap is filled with a gasket, held in place with 4 screws through a small block of wood. Note the check valve orientations. One allows air to be drawn out of the vacuum chamber, while the other allows the extraction cylinder to be emptied. The elbow off the T-fitting is not needed and should be ignored because it creates a larger dead space which acts like a rubber band during operation. The dead space is between the closed extraction pistons and both check valves. This space cannot be purged. The residual air in this space acts like a rubber band and diminishes results. The 1/2-inch pipe used for the extraction pump requires 50 to 60 strokes to empty the vacuum chamber, unobtainable with the large dead space. It also exaggerates the sawing effect by the threaded rod. So spend another $10 on more fittings. Create a larger extraction pump using the 1/2-inch pump cylinder as the gasket shaft of the larger cylinder. A sawed-off coupler and reducer create a hollow for a wrapped jean silicone gasket. Use a short length of the larger extraction cylinder to act as a clamp and a mold for the gasket. Start putting things together and cut the prior assembly to produce the nested pumps. Notice the external short pipes glued between the cylinders. This is a convenient way of welding the extraction cylinder to the vacuum chamber. The other end shows the chamber cap and the nested pump handles. Over time, the threaded rod will damage the T-fitting. However, the larger extraction pump displaces 9 times the volume of the 1/2-inch inner extraction pump. It also allows the dead space to be stretched prior to using the small pump to drag out more air. It takes 4 to 5 strokes of the larger pump followed by 4 to 5 strokes of the smaller to achieve 80% vacuum. The large pump speeds things up while the smaller gives a strength advantage. Use the smaller in combination with the larger. The check valves will leak, but whatever you are gluing only needs to be in the chamber a few minutes unless it off-gasses. Sandwich the parts between plastic wrap. If all goes well, it will clamp the parts together when the vacuum is released.